KNES 310. This is going to be a class for Wednesday, September 11th. So I am not going to, because the university canceled class, I'm not going to advance any new material. But today I'm going to kind of take advantage of no one here in the classroom to highlight the screen to try to develop concepts that maybe some students either are struggling with, no problem, because we all struggle with new concepts, or if you kind of understand the concepts, great, this will help develop and master those concepts even further. Nothing that I am explaining in class is entirely new. You have all had these concepts introduced to you before, just maybe not specifically with joints and joint motion. Rotational world, I've said that before in class. The key thing, or one of the key things, is to understand the difference between joint position and joint motion. The difference between where are you at and where are you going. And so I have this example that I know you guys have had before in high school and in college. The difference between position and displacement. Okay? Those are two separate things. Are they used in a similar conversation? Yes, they are both kinematic variables. They're both describing motion, but they're describing movement concepts two different ways. Position, where are you at? Displacement, how did you move? Makes sense. Motion, where are you going? So look at this equation that I know you guys have had before. Position X, where are you at? Displacement is your final position minus your initial position. And where are you going could simply be looked at in terms of the arrow. So like, let's say we're moving in the X direction, positive X, or we're moving in east, or we're moving west, north, south, whatever. So displacement, how did you change position? It's the same concept with joints. For my wrist, where am I at? I am either in anatomical position, I'm either in a flexed position, or I'm either in an extended position. However, I could be flexed 5 degrees, I could be flexed 10 degrees, I could be flexed 45 degrees, I could be flexed 80 degrees. So that's the equivalency with like miles, right? How many degrees am I extended from anatomical? How many degrees am I flexed from anatomical? On the test, I'm never going to ask you a change in position question inference of joint motion, where it's just going to be like 1 degree. Like I'm never going to say, hey, your initial position is at 5 meters, and then like shift the car 0.00001 meters where it darn near looks like it's in the same position, and then ask you how did it move. There's always going to be obvious position change. I look like a guy with a mask on. It's kind of weird. So change in position is displacement, movement. We can infer movement from change in position. Another slide that I have to kind of simplify the difference between position and displacement is here. These are two different things. Displacement is made up of change in position, but where are you at could be your initial position. Where are you at could be your final position. But unless I have the context, guys, you know what this is? This is a before and after picture. That's all it is. Having a tough time kind of seeing that. Huh? Let's see if I can zoom out a little. Let's see if that works better. No, not very good. Ta-da! Yay! Okay. So initial position is kind of where are you at? Final position would kind of be where are you going? And the change in those two would be your joint displacement, angularly, right? Rotational displacement. Where am I at? Where did I go? How did I have to displace to get there? How did I have to move to get there? Where am I at? Where did I go? How did I have to move to get there? I'm in anatomical. Now I'm flexed 90 degrees. I had to have flexion to get to that new position. If I start off flexed and I end in anatomical, where did I start flexed? Where did I end anatomical? How did I have to move to get there? I had to have extension. Make sense? Where am I at? I'm extended. Where did I go? I'm in anatomical. I had to have flexion to get there. Now, it's not even a trick. It's just we're not used to practicing these concepts. Let's say I start off in a flexed position and I'm flexed 90 degrees. And then, so this is my starting position, my starting joint position. And then my final joint position, I'm flexed 45 degrees. So I'm flexed 90 to start, and I'm flexed 45 to finish. A lot of students will just assume, oh, I am ending in a flexed position, I must have flexion. Because we don't stop and think position is not the same as displacement, as motion. How can I go from being flexed at 90 to being flexed at 45? I'm closer, not closer, I'm further away from fetal at 45 degrees than at 90. I had to have extension to get from here to there. I had 45 degrees of extension to anatomical position to get to my new position. Does that make sense? So even though I finished in a flexed position, I had extension in order to get to that new flexed position. Make sense? So in other words, just because I ended in a flexed position relative to anatomical doesn't mean I didn't have extension to get there. So very important to understand the difference between position and motion. No different than if I was going to, on the test, if I was going to ask which of the following is a letter, and I put A, B, C, and I put 1, 2, 3. Well, that's a very tricky question because I'd have 3 letters, right? So if I said, which of the following is not a letter? And I put A, B, C, and then the number 3. You would put 3 because you know the difference between letters and numbers. That's how we have to be with position and motion. On the test, I'm going to say, what is the position of the wrist? The position, where is it at relative to anatomical? And some of the answer choices is going to be flexion, extension. It's going to be tempting, but you have to understand that when I'm asking you a position, that's the 2 questions in the middle. Where am I at? Where did I go? Motion is change in position, direction of displacement. There has to be context to that. I cannot infer motion without context. Let me give you an example. Going back to the first picture. I can't infer motion without context, meaning that if all I had was this first car, it's supposed to be the same car. It looks different colors because this one's kind of invisible to infer that that's where it started and this is where it ended, right? But we have the context of change in position. If all I did was give you that picture on the right by itself and just said, how is that car moving? There's not enough information. I have no idea. That could be a start position. That could be a finish position. I could have paused live TV. So in other words, even if it was moving, if I paused it and I just walked into the room, I don't know how it's moving. I have to have context. With context, and guys, this is what it's going to be on the test. I'm going to have a before picture and I'm going to have an after picture. That's the context. I'm going to have a starting position, an initial position, and then I'm going to have a final position. And the displacement, the change in position, is what infers joint motion, rotation, the rotational component to that general movement that happens at joints. So starting position on the left, finish position on the right. Now I have context to say, that car traveled 10 meters to my right. That car traveled 10 meters in the positive X. Using an angle analogy, I start at 5 degrees flexed. I end at 15 degrees flexed. I had to have flexion of 10 degrees. If I started at 5 and I ended at 15, I had to have 10 degrees of flexion. Now, again, I'm using that analogy, 5 and 15, just because it kind of matches up with 5 and 15 for the linear analogy. But on the test, there's going to be obvious motion. It's not going to be these little things. It's going to be these big things. So I think that is the most important lesson for today. This is what I would love for you guys to practice. Joint position. Where am I at? And that is reference to anatomical. A joint could be in anatomical position, home, or it could be extended based off of anatomical, further away from fetal, or it could be flexed from anatomical, closer to fetal. Sagittal plane motions functionally are, am I getting closer to fetal or further away from fetal? Am I getting more into a ball or less into a ball? My wrist is in anatomical. I'm going to turn this light off and do some examples. Let's see. Yoink. Yoink. Let's see. Find. Okay. Let's see if we can see this. Oh, I think I know what I need to do. I need to close these off and turn on the others. Give me 1 second. Let's see how that works. Yeah, I think that's better. All right, so on the test, and again, guys, I know that your instinct is give me 1,000 questions. It's not how this class works. This class is understand the concepts that I'm trying to teach you so that you can answer 1,000 questions. Okay? And we're going to practice. I'm going to give you some, but it's impossible to give you all because there's infinitely many questions. So on the test, if I ask you for, I've already established which joints I can ask questions about, right? On the test, if I say, identify the position, the joint position of the knees, you would not say flexion because that is a motion, that is a displacement. And if all I have is this picture, all I have is one position. I have a final or an initial. I don't have enough information to say that there is flexion. I have to have more context. His knees start an initial in anatomical, and then he moves to this position in the photo. Now I have a delta. Now I have a change. Now I have context. But if all I did was say, hey, what's the position of the knees? The only thing I can say is those knees are flexed. They are in a flexed position relative to anatomical. Think of it like this. Anatomical is our universal reference so that we can compare. We can say, well, I'm flexed because I'm referencing it to anatomical. Does that make sense? His knees are in a flexed position. His hips are in a flexed position. Ankles, we'll get to that in the second unit. I told you guys on Monday, the reason we don't have ankles on the first unit is because ankles have two different forms of flexion. There's in the fetal with your feet on the ground, and there's in the fetal with your feet off the ground. Okay? Now, how can we infer motion? We can infer motion a couple of ways, but I need to have an initial and a final. He starts in this position, initial, and he pushes the plate up, and his knees start to move, start to displace towards anatomical position. Think about it. He's in a flexed position. You should know that from what we've been practicing. And his knees start to go home, anatomical. They're home. So if he starts in a flexed position and he moves his knees towards anatomical, the only way that's possible is for the knees to have bilateral knee extension to go home. If he started in anatomical and he moved to this flexed position, roughly around 90 degrees, he had that flexion to get there. If the hips start rotating back to anatomical, he would have hip extension. Now, if he straightens out his knees, knowing what we know about this machine, his hips will never be straight, right? Because he already started out in a flexed position, but that's okay. The hips are going towards anatomical. That doesn't mean they have to get there. If I'm in Baton Rouge and I'm traveling west on Interstate 10, I can stop in Breaux Bridge to get gas. I'm traveling west, even though I may not get to Lafayette. I may not get home. That's okay. So when his hips stop moving because his knees reached anatomical position, his hips would still be in a flexed position, even though he has extension of the hips to get to that final position. Make sense? Let's see. All right, more practice. Okay. Let's see. If you can't see this on the screen, go to your PDF materials, and it's on page 27. Page 27. So let's do some practice. What is my shoulder position on the photo on the right? The position. Where am I at? Where am I at? Position. I'm in a flexed position. My right shoulder is flexed relative to anatomical. I create a comparison because of anatomical, but that doesn't mean my motion matches up with my position. Motion is change in position. So if I said I start on the right, which I'm flexed 90 degrees, but I end on the left, Well, I had to have right shoulder extension to get there. Where did I start? Flexed. Where did I finish? Anatomical. How did I have to move to get there? Right shoulder extension. If I go from left to right, where did my shoulder start? Roughly anatomical. Where did I end? Flex 90. I had to have flexion to get to that new position. Motion is just change in position. Okay? Let's go here. Got to do some inference. But top left, extension and flexion. Remember I said you got to follow the fingers. That's the clue. Follow the fingers. The finger flexion, getting your fingers or fist into a ball will show you the wrist flexion. Because I can change my radial ulnar joint to change the global position of my palm, but this is still my palm. The fingers will show you flexion. The fingers will show you flexion. The fingers will show you flexion. So extension in this regard, where am I at? I'm going to start on the right. Where did I go? I'm going to start on the left, and I had to have left wrist extension to change those positions. And then vice versa, if I start in an extended position and I finished in a flexed position, I have to have flexion to get there. Remember, this is not hyper. Hyper is excessive, beyond a normal range of motion, beyond a normal road. It just so happens your elbow in anatomical position is at the end of its road of extension. So anything past that we would consider hyper, but your wrist isn't. Your wrist can have extension from anatomical. No problem at all. You see the dead dotted line? That infers your initial position. Sometimes these books don't go into detail of inference of change in position. That's why I'm here. So the dotted line says, hey, that's where you start. This is where you finished. I had to have flexion to get there. This is where I start. This is where I finish. I had to have extension to get there. Okay. Now, how we are going to communicate the nuance of extension is with anatomical. So the bottom would be extension from anatomical, and the top would be flexion from anatomical. But we can have extension to anatomical, and we could have extension from, flexion to, flexion from, extension to, extension from. Get into the habit of that verbiage. I've said this at least 3 times. It's no different than saying I can travel east to Lafayette, or I could travel east from Lafayette. I could travel west to Lafayette. I could travel west from Lafayette. East to, east from, west to, west from. That's important practice, because what that's going to do is stop us from assuming that just because I'm extended doesn't mean I have to have extension. Just because I'm flexed doesn't mean I have to have flexion. I gave that example right at the start of class. If I start 90 degrees, I flex 90, and then I end flexed 45, I had to have extension to get to that new position, even though I'm still flexed relative to anatomical. So I can have extension, but yet still be flexed. Okay? The bottom one is putting all of these together. The bottom picture. Start in the middle, anatomical. Flexion from anatomical. Extension to anatomical. Extension from anatomical. Flexion to anatomical. Flexion from, extension to, extension from, flexion to, flexion from. Why is this important? For a few reasons. Communication. If there is a wreck on the interstate, we need to be able to communicate to our first responders, to the towing company, exactly where people are. In other words, even mile markers are relative too, right? You get into Louisiana, mile marker 1, 2, 3, 4, 5, right? It's all relative. And so it's no different. What if somebody, someone has pain, but it's at a very specific part of their wrist motion? Initial pain starts when they extend, or they're extended 35 degrees from anatomical. That specifically gets me to a place. But if I just say pain with 35 degrees of extension, extension from here, extension from there, right? I have to communicate where I'm at so that I can move from there and I can specifically get to certain points. 35 degrees from anatomical gets me to a very specific point. 35 degrees extension from fetal, or from my wrist is flexed at 90 degrees, and then I'm doing resistance, and I start to have pain with 35 degrees of extension from a fully flexed position. That's a whole different place than extension from anatomical. Does that make sense? So that's why we try to communicate to, from, extension to, extension from, flexion to, flexion from, extension to, extension from, flexion to, flexion from. Get used to that. So the take-home points from today: nothing new, only developed. Know the difference between position, where are you at, and motion, where are you going. Where is the joint at is based off of anatomical position. I'm flexed relative to anatomical. So what's the difference between being flexed here or flexed there? Angles, right? That's where you go into, I have 5 degrees, 10 degrees, 15 degrees, 20 degrees, 30 degrees. Motion is change in position. Where am I at? Where am I at now? A start and a finish. Start, finish. How did I have to move to get there? I had that flexion to go from anatomical to being in a flexed position of 90 degrees. Remember, change in position is important because our eyes can only process so many frames per second. There's a lot of illusions with human motion, and the reason is because our cameras can't keep up with motion. It's too fast. That's why magicians always can do sleight of hand. They have the advantage. The hand is quicker than the eye? Absolutely. So if I could teach you to see changes in position, remember this example from class. Where am I at? I'm extended. Where am I at now? I'm flexed. The only way to go from being in an extended position to being in a flexed position is to have flexion. I had flexion to and flexion from. And I also had radial ulnar joint motion, but that's not going to be on the first test. In the fetal, out of fetal, flexions and extensions. You ever thought about like why there's so many different joints that have flexion and extension? Because they all have something in common: getting you in the fetal, getting you out of fetal. Finger flexion, wrist flexion, elbow flexion, shoulder flexion, cervical flexion, trunk flexion, hip flexion, knee flexion. We'll get to the ankle because, again, 2 different forms of flexion. Finger extension, wrist extension, elbow extension, shoulder extension, cervical extension, trunk extension, hip extension, knee extension. That's it. Those are the things you're going to be accountable for. I hope this helped. I hope this clarified some things, and I hope everybody is safe, and we'll see you guys on Friday.